In this example, I need to solve the equation, the quantity x minus 7 all squared minus 20 equals 4. Well, what type of equation do I have here? I could expand x minus 7 all squared, and I get an x squared term. So the highest power on any of the x's would be a 2, so I have a quadratic equation. And we often solve those by factoring or using the quadratic formula. But in order to do that, I would have to expand my x minus 7 all squared, and then I'd have to get it in standard form with 0 on the other side before I could even start to factor or use the quadratic formula. But we can solve this problem by a much shorter method using the square root property. Because if you notice, I have a squared term and just numbers. And in those cases, the square root property allows us to solve this problem quickly. So solving a quadratic equation by the square root property. This method is a quick method, but it can be used only if the equation can be written in the form u squared equals d, where u is an algebraic expression and d is a non-zero real number. So in these cases, the first thing we have to do is isolate the squared expression on one side of the equation and the number d on the other. So it looks like this. So once I get my u squared equals d, then we take the square root of both sides and we land up with u equals plus or minus the square root of d. Please remember to put the plus or minus in there because this equation has two solutions. So let's look at our example now. And I have a squared term and numbers, so I need to isolate the squared term. So I'm going to add 20 to both sides of the equation. And so I get my x minus 7 squared equals 4 plus 20 is 24. I have my squared term isolated on one side, my number on the other. So now all I have to do is take the square root of both sides. So the square root of x minus 7 squared equals, don't forget your plus or minus, the square root of 24. Well, what do I get when I take the square root of the quantity x minus 7 all squared? These undo each other, so I just get left with x minus 7 equals plus or minus, now simplify the square root of 24. 24 is not a perfect square, so I'm going to have to factor it. There's many different ways of doing this. And 24 is even, so it's divisible by 2. 2 divides into 24 12 times. And 2 divides into 12 6 times, and then 6 is 2 times 3. I'm going to combine these two 2's together to make 4, and there's no perfect squares hiding here, so I'm going to multiply 2 times 3 is 6. So my 24 I'm going to write as the square root of 4 times 6. Remember I said there's many different ways of factoring 24. If you'd immediately thought of 4 times 6, that's great. But it doesn't matter which way you factor the 24, you'll get to the same answer in the end. So I have x minus 7 equals plus or minus, the square root of 4 is 2, times the square root of 6. Because there are no perfect squares in 6, it won't simplify anymore. Have I solved this for x yet? No, I've got to add 7 to both sides. And so I'm going to get x equals, be careful, students want to often combine these, they're unlike terms. So I write them as 7 plus or minus 2 times the square root of 6. And writing it like this, students are again tempted to add the 7 to the 2 or do 7 minus 2. This 2 cannot be combined with the 7 because it is multiplied by the square root of 6. So they're unlike terms. I cannot combine them. So there are my 2 solutions to this equation. And if you're asked to write the 2 solutions separately, you'd write 7 plus 2 times the square root of 6, and x equals 7 minus 2 times the square root of 6. Remember, once again, cannot combine these terms, unlike terms. So that is the other way of writing your solutions.